Do you ever wish there was an easier way to align work on your laser bed? A better way to achieve repeatability when using a jig? Well, today I'm going to show you how I made an interlocking jig system for my CO2 laser. The same concepts that I show here will work on any type of laser. You just need to change the starter piece to fit your particular machine. And you must ensure that it doesn't move relative to your frame once it's installed. The first step in the process is affixing the honeycomb to the laser frame. Mine was already attached with a screw on either side when I purchased it used, so I don't know if the previous owner did that or if it came from the factory that way. Nevertheless, it needs to be affixed so it can't move around. This system will also work if you use the knife blades rather than the honeycomb bed. You just need to attach the starter piece to the laser frame, the bed frame that raises up and down, rather than the honeycomb itself. So let's get over into Lightburn and I'll show you how I made this. Alright, so we're in Lightburn and we're going to start by going to our units and grids and settings. And I have my grid spacing set to 10 millimeter with my snap distance of 1. My control arrow is set for 1 millimeter. My plane arrow key is set for 60 millimeter. And my shift arrow is set for 30 millimeter. And I'll explain those settings in just a moment. So I want my total distance from the back of the starter piece to the front of the teeth to be 50 millimeters. So we're going to start here at 50. I'm going to use the line tool. So click on right at the 50 and 0 and move over to 10, and we're going to hold the shift so it stays constrained. Click there. Now we're going to go back 10 millimeters, again holding the shift so it stays constrained, and it will snap. Now we're going over 5, which is right there. Shift, click. Now back to the 30 millimeters, so we're going back 10 more. Shift and click. Now we want to go across 20, which is going to take us here to 675. Shift, click. Back up to 40. Shift, click. Click here. And hold on to shift. Shift. Shift and click. And then come over another 10. Shift, click. And then we right click to escape out of that. Click on the arrow key. Now just to verify dimensions, I'm going to use the ruler. So we have 10 millimeter here, 10, 5, 10, 20, 10, 5, 10, and 10. Okay, those are the dimensions we're looking for, and everything should be perfectly square because I held the shift key down at every click. So now I'm going to select that and copy it by clicking Command D or Control D if you're on a PC. Now I used the shift arrow key, hold the shift, and that moves it over exactly 30 millimeters because that's the dimension from here to here is 30 millimeters. So I was able to move that one time and they line up perfectly. They're not joined, they're still separate shapes, which is fine. We'll fix that in a moment. Now I select both of them, Command D to duplicate, and then just hit the right arrow key one time. That moves over 60, and you can see now it's moving one at a time, 60 millimeter, 2 teeth. I'm just going to keep repeating that until I go all the way across. Command D, arrow, Command D, arrow, duplicate arrow, duplicate arrow. We're almost there, a couple more times. Oop. Okay. So now we're all the way across. I'm going to select all and edit auto join selected shapes. Now I'm going to join it all up using the line tool. Go in here, click there, come back to my very back line, hold shift so it stays a straight line constrained, go across. I'm going to come in here to this line, shift and click, and come up to this one right here, let it snap in place, shift and click, and then right click to exit that. Hit escape again to exit the line tool. Now in version 1.7 or above we have the scissor tool. So I'm going to click on that and show you. Now we can just hover over this extra part that we don't need and click on it and it deletes it, it's gone away. But if you're on an earlier version you have to do this using the node editor. So let me back up, put that piece back, and we'll switch to the node editing tool. And now The scissor tool is really just came from the node editing tool. The tool already existed there. It's just a little bit easier to use now that it's on the front page. So I'm hovering over this section right here. I'm going to hit the T button to trim it back. And that trims everything that's hanging out all the way back to this point. And now we have one shape. See how it's joined together already? We'll undo that. And we can click out of that. Okay. And now we want to move it to center. That's centered. And I'm going to change this to a cut layer. And I'm going to add just a little target piece here. Hold shift to make a round circle. And I only want it to be 10 millimeter. That's 10 millimeter, and I want to change that to blue. Okay. Now we're going to drag that down and put it right in the center. Click on here. That's centered. Okay. We'll go to our material library, and this is a score line. I'm going to assign that. Change that to fill. And click on our red layer here. That's going to be our cut. Assign. And we want to move it down to the end so it does the fill first. Okay. Now one other step I need to do is I need to add a kerf offset to my cut layer. And I know that with my 4-inch lens that I'm using in this particular material, I need a 0.2 millimeter kerf offset. So I add that right here, outward. And then when I cut the mating pieces, I don't put a kerf set on those. I just use a standard cut, and they fit together very nicely and nice and tight. So let's take and send this then to the laser and cut it out. And there's the finished product. Now we'll replace the existing one with the new one and get into making the mating pieces, the actual jig fixtures. I'm removing the old fixture. Then I take it and place it on top of the new fixture and use the existing screw holes to line up and run holes through the new fixture. That way I can use the existing screw holes that are on my honeycomb bed. If you've never installed one before, you can just align it with the back of your honeycomb grid and use some self-drilling screws and just attach it. But since I've already had this attached, I don't want to keep drilling a bunch of new holes. So I just used existing holes. And there it is, permanently affixed to the honeycomb grid. Now we can move on to making the attachments. Now we're back in Lightburn, and we're going to work on making the mating pieces to go with the starter strip. First thing I want to do is select all this, duplicate it, and move it up out of the way. Okay, and I'm going to just make a text note in here. There's a starter strip, we need to add kerf. Okay, and we'll change that to a tool layer and group all this together for future use. In our next step, what we need to do is zoom in. I'm going to take this guy and move him into there. So we'll always have a matching place to go to. And let's get with the node edit tool. I want to click D, delete that one, and delete that one. We no longer need this as a closed shape. We just need a straight line here. Now let's go in here and make sure we remove the kerf offset. because we will no longer need that. Now we need just a straight cut, because the kerf offset was already added on the starter up here. So any pieces we cut to go into it will be just a normal straight cut. And we'll go into our node editor, and we need to extend these lines out. I'm going to hold Shift, select this very end node, and drag it out to where it lines up with the end of our workspace. And do the same thing on this side. Hold Shift, drag it out. Okay, we're done there. We can actually group these two, they can stay together. All right, now I'm going to cut this on the same piece of plywood that I used for the starter piece. You'll see that it already has a teeth on there that is the opposite side of this, but because of the kerf offset and because of the kerf that's taken out of it, if I put that together, it would fit very sloppily. So we're going to cut this piece on the end of a plywood and stick it in place, and then I'll show you how we make the L fence. So let's go ahead and send this to the laser. And those two fit together very nicely. Now back in a light burn, we can take and move this out of the way. We're done with it. And we'll need to start making L fence. So I'm going to start with the line tool. Go right up here, make sure I'm on the 0, 0 mark. Click. Shift way out. Now I go to 650. Which is there, and then down here, let's come, I don't know, about 150, I think, 150, 160, something like that. Shift, click, and shift, click to bring it right out to the edge, and that's done. And we need to change that to a cut line. Select tool first, change that to a cut line. And then when that cuts, that's going to cut at 0, which is exactly the back of our laser working area, and then make a perpendicular 9 at 650 millimeters, and then just cut it off on the end. But one more thing I want to do, just so I know for future reference, I want to put 650 and 0. And we're going to change that to escape, change that to blue. Escape, change that back to red like it's supposed to be. If I click on the comma, it's going to rotate it 90 degrees backwards. I'm going to place this over in this area here, so that'll be permanently etched onto the jig. So when I grab it, I know that this corner coordinate right here is 650 and 0. So when I set up any kind of workpiece on my light burn, if I put this left edge at 650 and the top edge at 0, I know when I place it against that jig, it's going to be exactly in that location. So now I've got the other piece in place attached to the starter piece. We can just go ahead and send this. All the settings will remain the same for cutting and engraving. So hit send. Now I have a fence with known coordinates that I can use with light burn to place any jigs, fixtures, workpieces, whatever I want in that location at the top left corner at 650 and 0, and it will always be aligned perfectly. The reason that I use 650, you could do this as well if you want to make the L on the right hand side. You could do that as well. The only reason I did it to the left side with 650 is because that's closest to mirror number 2. and just less margin of error the closer you get to the mirror, I think. And the reason I use 650 instead of going all the way 700 is because I wanted to leave some room for overscanning. So no matter what I'm engraving, I don't have to worry about it. If I put it at 700, I wouldn't be able to get all the way to the edge with any overscanning. So I just moved it in 50 because that's a nice round number to deal with. But I'm going to also do a fence at 700. So let's go back into Lightburn and show you how we got to do that. There's a little bit of extra finagling to make that all work out. Back in Lightburn, we can take this here, the 651, group that together for later, and just move it up out of the way. We don't need that anymore. Now we'll take this and bring it back down. Okay, and I'm going to ungroup that because what I need to do is, in order for this to work with a 700 millimeter fence, there's such a very little bit of meat left on the wood if I cut it that way. So I'm actually going to shift it over one notch, and you'll see what I mean by that in just a minute. So we can go ahead and leave that. Try it again. All right. You can see here where I had to actually take it off and cut it with my chop saw because the laser couldn't get over far enough because I'm cut outside the bounds of the bed. And I actually had to cut it at a bit of an angle to clear the post. And also I ended up moving it over 2 notches instead of just 1 before I made my final cut on it. Group that back. Move this up out of the way. Now we're going to make our line for our 700 millimeter fence, and I can actually start in about 10 millimeters from the end now because we had to shift it over. There, go all the way over to our 700 mark, shift click, and then come up, like I say again, about 150 or so. And there. Okay. Done. Change that to cut layer. All right, that looks good. Now I'll go ahead and cut this part out. Now we're back in Lightburn, and I can actually get rid of this line. We don't need that anymore. What I want now is a text layer. And hit the comma to go reverse direction, and we'll put that right there. And we're going to reposition the 700 millimeter fence and burn the numbers in it just so we know where it goes. And now we have a fence at 700 millimeters. So there we can use that for cutting purposes. Not so good for engraving, but it's great for cutting. We have a fence full width of the bed, full usage of the bed. And you can do the same thing on the other end, like you said, if you want to. You can make it at 0 instead of 700 and come from that direction. But I just choose to go from the left side to the right and just work backwards with my numbers on my axis. I'm going to give you a real quick practical example of building a jig using this system. So here I have the starter piece in place, and I'm going to put this on a piece of 12 by 12, 300 by 300 plywood. I'm going to make this a square, 300 and 300. Okay. That can actually go there. All right, so we have our starter piece here. I have my square, and I'm just gonna actually move it over. I want to keep it over closer to the edge. I'm gonna put it right there. Okay. Now with that selected, I'm going to take this, make sure it's all ungrouped. That's ungrouped. I'm going to use the node editor and zoom in, hover over that and click the D button. From this side, hover over that, hit the D button. Get out of node editor, select that, delete it, select that, delete it. Now we have a little extra hanging over. I'm going to go back into node editor. I like to make sure it cuts all the way through and just extend this out. Hold shift so it stays constrained. And do the same on this side. Give it a little extra, hold shift, right click, we're out of there. Okay, that part's done. Now unfortunately this does have to be done in 2 steps, because you can't cut the teeth, the starter teeth, and the jig at the same time, because where the starter teeth go, everything has to move farther into the machine, and I don't have an exact number of it because that always varies a little bit. So let me turn off the black layer, and that should be ready to go. That's ready to go. Let me go ahead and, oh, I don't have the right settings here. Let me get some settings quickly. That's fine. And just a 3mm cut. Okay. Let me go ahead and send that to the laser. That piece is cut and it's laying back in the bed. And now what I did was took, with it laying in position, I measured from, actually laid the 700mm fence on top of it and measured to this point right here, which is 116mm. So we got to go 700 minus 116 is 584. That's where that should be at. And we lose about 50mm for the teeth and the extra space before the start of my cuttable area. So let's change this to 250 and drop this guy down to 1, so it's just below. Okay, we can get that out of the way. This will now turn into a tool layer, and that'll get locked in position where it's at. Now we're going to take and make a box, and our cards are 86 by 54. Make that a cut layer. And we want to add a finger hole. Something like that. Zoom in. Bring this guy to where it snaps there. Shift and select. And center it horizontally. And then we're going to do a union. Okay. Now we'll come over closer there, and now we're going to do an array. 2, 3. Yeah, we can't get 4, and I think we're only going to get 3 this way also. Yes. Grouped results. And now we're going to shift and select our tool layer and center everything up. Okay, that should do it. I'm going to send it to the laser and then frame it and cut it. And it should be just right. With that cut out, now we can take all the red layer and turn them into a tool layer as well. And right click, lock those. Now everything should be locked. We can't move it anywhere. It's just stuck there, which is what we want. Now, because the aluminum business cards I have are so thin and the plywood is slightly warped, I actually left the cutouts laying in place and just have the business card sitting on top of them. So this isn't necessarily the best example, but you will get the idea what's going on here. So now I've got 6 cards, the first 6. Let me get a design going here. See if I have something. Yeah, I'll just put my logo. Just put my logo on here. Let's see, they're 54 tall, so I'm going to be, let's do 40. Let's just do 40. Okay, shift. Oh, we can't do it that way. I'm just going to do them by eye, because this is only for an example. Let me group my logo together here, and then do the array. Okay. Oops. Looks good enough. Good enough for a test. We're just going to make everything default and see what that does for me. 2 minutes. Okay. And I want black. Yes, I want black as well. Okay. So now we have 6 business cards in place. I don't know what they're going to look like, but let's go cut them or engrave them. Well, those aluminum business cards didn't work out too well. I knew I didn't have the right engraving settings on them, but I also had the air assist on, and as you saw in the video, they just blew off once it got past that certain point. So I just stopped it. There's no reason to continue on. I mean, the objective here was to show you what you have to do to create a jig, to cut a jig, to design a jig, to use a jig for, whether it's business cards like that or keychains or anything that you can have that's repeatable, coasters. In fact, I have a coaster jig that I have set up already, and I'll show you a little bit of that in a minute. That does 20 coasters at one time. And I also have my rotary set up on a piece of plywood so that when it goes into the bed, it's locked in position, the same place every time, and it's always square with the x-axis. So it works out so much better that way. So let me just show you my rotary jig and my coaster jig, and we'll wrap this video up. Here you can see me placing my rotary jig into position. Once again, it just locks in with the interlocking teeth, and it's absolutely perpendicular to the bed where it needs to be, and it's always in the same location. Works great. This is my coaster jig on the work bed, and you can see it's actually 5x4, so I can do 20 coasters at one time with this. So each box here corresponds with the box on the coaster jig, and this round circles, if I'm using a round slate coaster, you have to, since the edges are rough on them, you need to just kind of stay in from the edges a little bit. Same with the square ones. So this round tool line is for the round coasters. The blue tool line is for the square coasters, and the outer tool line is where they actually lay in. And I can put whatever design I want in any one or all of these, and I can do 20 at one shot. And it's so repeatable because this jig never moves. It's really a great way to work. It makes your life so much easier. You don't have to spend time trying to position the jig and fire the laser and make sure that everything is just right, and twist a little bit and go to the other side and reline it up, or use the print and cut feature like a lot of people do on that, which does work. It works very well, but this is just so much faster because it's always in the same location. So let me know in the comments what you think about this jig I made. It's not my original idea. I saw it on the Clack Shack and just modified it to my specifications a little bit. And I don't know if it's an original idea with him either, but you know, just like everything else in this world, there is nothing new under the sun. So hope you found this information useful for you. Please like the video, please subscribe to my channel, and we'll see you next time.